Good morning, ladies and gentlemen. Again, here in New York City. Good morning, good afternoon, good evening if you're following day 2 of Cloud Expo here in New York, out there on the World Wide Web. Abiquo are up next. This is a company growing as fast as Cloud Expo itself. You can draw some conclusions from that, perhaps. But one of the virtues of Pete Malcolm, CEO of this company, is that he cuts his coat according to his cloth. So here we are in New York, and look at the title of this presentation. Is he really going to be able to pull off a prezzo asking that question? Let's find out. Are financial service organizations risking security by avoiding cloud computing? Pete Malcolm, please. Oh, he's going to jump.
Good morning. Let's see, great. So I'd like to talk about this question, but we need a few things to go through first. The first thing is that it's a general belief that financial services organizations have really shunned cloud computing so far because of the security and compliance concerns. But their users and developers love the idea of public cloud because it gives them that flexibility, that convenience, but a huge risk. And the situation we have now is that a lot of developers, users are going to public cloud because of that convenience, but it's producing a huge risk for the organization. And what we need to look at today is, can we bridge that gap? So a little bit of history to begin with. It's important to understand where both of these two worlds came from to understand about the solution. So the infrastructure as a service, the self-service model that the developers love, really started out of the Amazon Web Services model. Initially, that was driven through APIs aimed at that test dev market. And it required you, and still to a large extent does require you, to build your applications for that, or at least to convert them so that they will fit into that model. Because there are various restrictions that apply to you. Flavors of servers, for example, in Amazon's case, there are 3 different sizes of server. You need to adapt to the various storage models. You know, originally with Amazon, it was just S3 storage and storage in the volume. You needed to write your application to work with those. Now, that's changing over time, but it's still true to a large extent. And then from that, we got companies who built solutions that were essentially mimicking what happened at Amazon. And the idea of these was that you could build your own private cloud on-premise and use exactly the same functionality, give your users that functionality. Again, based on the Amazon API, typically a superset over time. Storage was still limited. Additional hypervisors started to be supported, although typically only one at a time. And then we progressed through to the current situation where we have new open systems like OpenStack coming to be available now in a fully open model that addresses compute, storage, and allows you to maintain image libraries. So that's kind of one path, but it's not the path that the enterprises come from. The enterprises come from this traditional client-server model that's been with us for nearly 30 years now. And this is obviously consisting of physical devices and applications, enterprise applications being built for them, developments like storage networking, enterprise management tools, high availability tools, additional security as time has gone on, and ultimately virtualization. That's the path that the enterprises have flowed through, and you can see that there's a distinct difference between those two. And that's really the gap that we're looking to try to bridge. So let's consider the public cloud for a moment and look at the benefits. We all understand the benefits. It's great. You can provision things really rapidly. Tools have been added to what was the basic Amazon AWS system to give you, the ability to do that visually. You don't have to have APIs anymore. You can get rid of all those delays that, in an enterprise, you have to go into your IT infrastructure team and have them go provision what was a physical server and now a virtual server. You can get rid of all of that process, and you can do it yourself in very small amounts of time. What you want, when you want it. You can have a pay-as-you-go model, so there's no big capital outlay. So you can do those short-term projects and all that kind of stuff. And there are pre-built configurations which allow you to do this really rapidly. And this has developed into a very beneficial system that is being used widely, principally by smaller organizations. If you took the kind of Amazon model, I think you would find that there were more SMEs doing things there than there are enterprises. But there are some very specialist applications. Netflix, for example, is one that comes to mind, where the entire thing is run in the cloud, but that's a very particular model. There are concerns, however, from the enterprises about how this stuff works. It's great, but it's got issues. And the primary issue is that public cloud is a black box. You submit your application to it, you connect your users to it, stuff goes in and stuff comes out, but you don't know what's going on inside. You have no visibility and you have no control. And for enterprises, this is a big deal because of compliance and governance and auditing and security rules, you cannot know exactly what happens inside that black box. And that's a big issue if you're trying to deal with Sarbanes-Oxley compliance or those sorts of things, and you have to be able to trace exactly what is where. Things are moving around, you don't know. And we'll come on to some specific examples of why that's a big deal. And you have no control, except in a very limited sense. You can typically decide on a particular geography that you want your application to run in. So Amazon has East, West, European. You can get that far, but not much more granularity than that. You're obviously sharing devices with other users. You don't know who and you don't know what, but you're clearly sharing physical devices with other people. And there are issues about resilience, and again, we'll talk about some things there, because your ability to test resilience is more limited than it is in your own physical data center. So let's just take a couple of examples to illustrate what I'm talking about, and these are very recent examples. So we all heard about the issue that Amazon had, which were, as you see this New York Times headline, raises cloud computing doubts. Now, the issue here is not about Amazon reliability. I think that if any of us, by any standard, looked at the reliability of the Amazon platform over the 5-6 years that it's been out, it has been incredibly reliable. Yes, this was a bad blip, resulting in a 5-day outage for some customers. But some things happen that you would not have expected to happen. For example, Amazon's availability zones, which you would have thought would protect you against one particular thing going out, would give you resilience, in fact didn't. Because the particular type of outage was not one that was expected. So we, for example, lost our download servers for 5 days. Now, that wasn't such a big deal to us. We had, we could simply, make other arrangements by changing our DNS entries. But many people who had much more complex applications than that couldn't do that. And so there were a lot of people who were out for those 5 days. Thousands of businesses were affected. But interestingly, the Amazon service levels were not actually breached. And this is a very good example about, if it's not yours, if it's not on your premises, if you can't test it, you don't know. And perfect illustration of that. So the issue is not that Amazon failed, but the lack of visibility and control into that system caused the failure to be unforeseen. Second example, the Sony hack that took place recently, where the second largest online data breach in US history, thousands of names, addresses, credit card numbers. I don't think anybody knows exactly how many, but it's a lot. The interesting point is that that hack was run from servers at Amazon AWS. And no fault, again, it's no fault of Amazon's whatsoever. That's not anything they could reasonably do anything about. But it does, again, raise interesting questions. The issue is not that the hackers used Amazon, but whether enterprises want their applications running on potentially the same devices that the hackers are running their code on. Think about what that actually might mean. So, summarizing the risks that the enterprises see, clearly an information security risk. If it's not inside my firewall, if I can't put physical stuff around it, that raises concerns. Clearly it raises concerns from external hackers. It raises concerns from the employees of your cloud provider. You know, they can go and open the lid and look inside. That's clearly a risk that doesn't apply in quite the same way if it's inside your firewall. And now we have a new potential risk. What else might be running on that physical box that other people can put there that might be trying to examine what I can do? Supposed to be impossible. All of these security breaches are supposed to be impossible, but they still happen. There's other code running on that box that I don't know about. That's an additional risk. The compliance and governance issues, how can I be sure that I can, for example, maintain the Chinese walls that I, by regulation, have to maintain if we've got stuff sharing the same device? In the financial services industry today, research and investment banking exist in separate places. They don't get anywhere near each other. That's much harder to do if you're talking about doing this kind of stuff in the public cloud. And how are you going to audit exactly what is going on? How are you going to trace exactly where every application was at any given time? Because the whole point about this stuff is that things can move around. The resilience question we've mentioned, you know, can I test all of the scenarios that I need to test to make sure that there's going to be resilience in all circumstances? Because I don't control that thing. And clearly, some of the people at Amazon were not, no, users of Amazon were not able to test all of the resilience situations because the resilience didn't work. Co-location. There are some times when I need to ensure that I have two applications running in the same space for performance, or I need to ensure they're not running in the same place for resilience. How can I prove that that is happening? The only way I can do it really in these course levels that we're talking about is to actually put those things in different geographies. But the co-location bit, trying to get them in exactly the same place, is much harder. And then we have a few other issues and risks that come in as a consequence of this. And it's really only the Sony issue that came up recently that started to make people think about some of these things. In the US, we have this thing called the Patriot Act. The Patriot Act means that the FBI can walk into the Amazon data center and go and demand to see the machines and see the storage systems upon which those hackers were running their applications. And when they do that, they're going to see stuff that the hackers were doing. They're also going to see what else was running on that machine. That's an additional risk. You cannot separate that data out. You cannot say, look at that disk drive, it only contains what the hackers did. It won't. It will contain other stuff as well. And that raises a whole pile of additional concerns that would not necessarily happen in the same way if it was inside your firewall, because it would only be your data, and there's no risk of the FBI looking at what's going on there unless it's your stuff they're trying to look at. We also have the issue of cost. Clearly, it's to Amazon's advantage to have you spend as much money on their platform as you want, but that's not what your IT department wants. It needs to be able to control cost. Difficult. And lastly, a lack of portability, actually moving applications between your running in your data center in perhaps a private cloud or even on traditional virtualization and moving to an application in the cloud or back again is difficult. It's not a straightforward process. It certainly isn't an immediate thing that you can say, oh, that thing was running at Amazon, I'll just bring it up in my data center because that failure has occurred. You can't do that stuff. It's a complex task to move them. So let's look on the other hand about the private cloud. And the first point is to make here is that there are two types of private cloud solutions out there. Those that are simply public cloud that have been made to run inside your firewall. So essentially a clone of Amazon or something very similar that is just running inside your firewall. That doesn't really address many of these issues we've talked about. And then there are those which are built from the ground up to address the needs of the enterprise. They're coming from the path of enterprise progression that I showed at the top of the presentation rather than from the IIS side. Let's just explore a couple of the issues around private cloud and what has caused some of that stuff to happen from the enterprise perspective. Enterprises have done quite a lot of adoption of virtualization. There are questions about how much of that has been done in financial services, say, exactly how much of their data centers have been virtualized. Some people suggest it's lower than 30% of, I don't mean of the whole data center, but of servers in general, less than 30% have been virtualized. Why would that be? And these are the sorts of issues that will resonate with most people who have virtualized environments. As you grow, you get an overwhelming amount of volume. You get sprawl. It's very difficult to work out what's where because it doesn't stay where you left it necessarily. It's not like a physical machine where you put it on that machine and you go to that place in that rack and you'll find it. Stuff moves. And you have a disconnect between the IT infrastructure team and those people actually running the applications. So I'll give you a very simple example of that. You go and have your virtual machine provisioned by your IT infrastructure organization, and takes however long it takes, and you get it and you start using it and all those sorts of things. At the time when you finish using it, how many people actually go back and say to the IT team, the infrastructure team, I'm done? It took you so long to get the damn thing, most people will keep it hanging around, save it for a rainy day, use it for something else. And that, of course, destroys your cost savings. So that's one example of the disconnect between the IT infrastructure guys and the application guys. We talked about a high provisioning effort. In most large enterprises, even though virtualization has been introduced and the idea is that would make things much quicker, in reality it doesn't make them much quicker. It can still, in many large organizations, take you weeks to get even a virtual machine provisioned. Very poor capacity planning and utilization. Again, virtualization was supposed to be the nirvana for utilization, try to get us up near that magic 70%. We haven't got anywhere near that. We have increased it using virtualization, but we're nowhere near 70%. We're maybe half that at best. So that means that the cost savings that virtualization promised really haven't been delivered. Now, many things have been delivered. Portability, resilience, all that. Virtualization's done a great job of those, don't get me wrong. Security and compliance are big issues, as we've talked about. Even in your own virtualized environment, how can you trace exactly where everything is at any time? In a virtualized environment, how can you make sure that research and investment banking aren't on the same machine? How can you deal with other issues? For example, in Europe, it is illegal to send HR data across a country boundary. How are you going to enforce that in a completely virtualized environment? That's where stuff moves. Every time somebody provisions something, you need to make sure that you check it's compliant with that. And lastly, the issue of vendor lock-in, big issue with a lot of enterprises. A lot of the stuff is stuck on particular hypervisors, and they would like more portability. So let's look at a model of how this might work in the future. And this is the kind of Abiquo vision of how this stuff goes. If we take the gray circle around the outside of that diagram, this represents the physical infrastructure, physical servers, compute, storage, networking. And that could come from a whole variety of different sources conceptually. It could certainly come from local data centers that you own, other remote data centers in your organization. It could come from, buy it in from a hosting provider, get it from an IIS, public cloud type provider. The idea is that there will ultimately be a market for buying resource at whatever the best available price you can get it. That's the ultimate destination here. And those resources all contribute to this notional thing we call the resource cloud. And it's delivered at whatever service levels you demand to that resource cloud. And then it's consumed by virtual enterprises in the center gray ring there. And virtual enterprises are autonomous units. I'll go into a bit more detail on another slide. But they're autonomous units which appoint their own users and operate their own applications. They can launch their own virtual machines. They can consume storage. They can define their own networks. All of that in a complete self-service model. And in the center there, we've got the image libraries, which are essentially used as a service catalog so that you can decide and have things ready for people to whether they be applications that are fully built and tested and you just launch them, or whether they're down at the operating system level. Here's our standard Windows 2008 server with these service packs and this antivirus and those management tools to meet our corporate standard. They're all ready in the library for you as well, just to make things really convenient for those enterprises. But the key here is when you actually launch something as a virtual enterprise is where you actually deploy a virtual asset. Because then it has to be mapped to somewhere in the physical world. It has to go and actually exist on a piece of hardware somewhere. And that process is absolutely key to resolving all of the issues we've talked about. the utilization issues, the security, the compliance, governance, all that kind of stuff. This is the key defining moment at which these issues are resolved or not. And in most of today's virtualized environments, those decisions are made by humans. And just to give you an example, if you have a data center that has 1,000 servers in it, how is a human going to decide which is the most effective server to put a particular new virtual machine on? He does this. That isn't going to work. That is not going to get you. If you've got 10 servers, maybe. If you've got 1,000, forget it. And consider all of these other things we've got to consider as well. So in our model, we're built on three foundations here. The separation of the physical infrastructure from the consumers of that infrastructure, of that resource, the delegation of authority to virtual enterprises to do their own thing, and the automated allocation according to an allocation policy, or what in fact we call a business policy. And then the multi-tenancy comes as a factor of that, as does the image libraries on top of that. Let's just look in just a tiny bit more detail about what we mean by a virtual enterprise. And other people have different names for this, but what we mean by a virtual enterprise is an application unit. So for example, maybe in our organization, it's our trading application. And we want to define this enterprise as our trading application and set the rules around how that can operate. And so first of all, we have our own set of users. And as the administrator of that enterprise, I define my own users. I have complete control over what those users can do. I can appoint new ones. I can get rid of old ones. All of that stuff. I have my own user environment. Then I have a set of virtual data centers. And again, this is just a way of splitting up my enterprise into logical units and doing different things in different ones. And they may be geographically located, however I want to divide them up. But in this instance, we've talked about trading operations in New York and Tokyo. And then in each of those virtual data centers, I can define and create my own compute, storage, and networking. Exactly. Imagine each one of these virtual data centers is just like a physical data center. You can do everything you want to in there. You can launch your own machines. You can define storage, all of that stuff. But you don't have to maintain any of the hardware. The infrastructure guys do that for you on the outside of the ring. So let's go into a bit more detail about this business policy and how this resolves it. And I'm going to talk briefly about, or show you examples of these. These are just examples. There are many more, but the same principles apply. Here's one around utilization. There are two basic models you could use for utilization. One is the performance model, and you'll see here these little blocks flying around are showing you an illustration of how, in a performance model for utilization, you spread your load of virtual machines across all of the physical hardware you've got, so just illustrated by the servers in this rack here. And that will obviously give you the maximum amount of performance, but it'll also cost you the most as well. You might want to do the opposite of that, which we call progressive, whereby your policy automatically fills each machine to whatever the required or whatever the designated utilization level is, say 70%, until that machine is at that level, and then you start using the next machine. You can also then, as you see things start to go away, you can backfill the holes automatically using that policy. Okay, so see when there's a hole made because a virtual machine has been taken away, fill it back up again. Okay, do that very efficiently. You can also deal with the power situation, because we don't need to turn those servers on until we're actually going to be using them. So here we're saving a huge amount of power and cooling. Clearly, if you take the performance model, you won't do that because they're all on. So with the progressive model, lots of good cost savings. But there's another thing you can do with utilization as well. Imagine that we get to a situation where we have started to use up all of our physical resources. We're running out of physical resources. In this diagram, we're at 93% capacity. We're going to run out. And that's because we've set our utilization level at 70%, and we've only got that top server left to us to put new applications on. So in the ordinary world, what you'd have to do now is you'd have to go and buy more hardware from wherever it is. But say that's not an option right now. We're at the end of the quarter. We've got cost savings in place. We don't want to go spend more money. Using this business policy model, you can change your utilization level from 70 to 75 to 80%, for example, and now you've freed up a whole lot of resource which can be backfilled without you spending a dime on additional hardware. Now, clearly that's not a sustainable thing. You can't do that forever, but in the short term, changing your utilization from 70 to 80%, your users probably won't see much difference. You can do that in a controlled way because of business policy. Second thing, you can set resource limits as to what your virtual enterprises can consume. And this is in terms of how much RAM, how much virtual CPUs, local hard disks in the hypervisor images, external hard drives on those EMC, NetApp devices, whatever it is you've got there. The number of networks, the virtual networks the enterprise can create, the number of public IPs that they can consume, all of those things can be set as resource limits. And whatever the enterprise does, it will not be able to exceed those limits, and you can have warnings about when they're going to, you're getting close to running out and all those sorts of things. Not only do you have limits imposed on you, the enterprise can also, the administrators of the enterprise can also place limits downward on the virtual data centers within that enterprise. And you can see you rapidly get to a tree structure here where each person can impose limits downward on the rest of the organization. And that gives you a phenomenal level of control. You can set permissions about what physical data centers an enterprise is allowed to use. So if in my example earlier I am the UK HR enterprise, I can have policies set that says those data centers physically located in the UK are fine for me to use, but I cannot use one in France and I cannot use one in Italy, because I know in doing so that would potentially cause my data to cross a country boundary. As long as that rule is set, doesn't matter, I can go ahead and use the system however I want. I know that that rule won't be broken for the UK HR organization. I can reserve hardware to be used by a particular enterprise or by a particular virtual data center. This is, again, it's very important to enterprises because you very often find that equipment was purchased for a particular purpose, for a particular application. Those super fast servers I bought to do this task need to be used by this task, but I want them to be still controlled within my overall private cloud. So you need to make sure you have the capability to do that. And then setting restrictions as an example. Here is, for example, where we would say, I do not want any sharing of hardware between my investment banking team and my research analysts. I'm taking a very coarse example here, but so that might apply to storage devices, it might apply to servers, or it might apply to a more, a less granular level. It might say those guys are not allowed to share a rack of servers or even a physical data center if I want to choose to do that. So those rules are applied behind. The user doesn't need to see any of this stuff. What about some of the other requirements that are needed? Auditing is a very good example. I need to be able to go and say, okay, this particular application, this particular virtual machine, I need to know where in my physical infrastructure it was over its entire life, if necessary. And here is the sort of report that you might get to do that, that takes you from the moment that thing was created and gives you a report that says exactly on which physical hardware it was running and when it changed, whether it was moved by the user redeploying it, whether it was moved by a third-party tool, like, for example, VMware's vMotion could move it to another place. You need auditability of exactly all of those processes. Who did what, when, and where was it? View inside the black box. Now, you may choose who you give that information to. You may not give it to the end application users. This may be only available to your compliance people. But you still need to have it. Essential requirement. Other requirements, we talked a little bit earlier about portability. We must have unrestricted flavors. In order to make this thing work, it's no good saying, okay, there are only 3 flavors of server you can have. That's not going to work for an enterprise. They've, a myriad of different flavors they have already. They need to maintain those. You can't be restricted by 3 different flavors. You need to be able to have the ability to move an application, running on a virtual system from the private side to the public side and back to the private side at will. It's no good having to go and rebuild your application, reconfigure stuff, all of that thing. It's not going to work unless you have that level of portability. Otherwise, if something goes wrong at Amazon, I don't have the ability to get that thing working back in my data center or some other data center really rapidly. We have to evolve where we've got a situation that does that. We have to have standards, and there are fairly few standards in the cloud today. We need a lot more standards around making that portability happen. OVF, the Open Virtualization Format, is a good start, but it's only really a wrapper. And we need to also think about not just moving our servers, as most of this discussion has been about, but you need to think about moving your storage as well. The associated storage volumes may need to be mirrored in different places, may need to be able to be rapidly moved. A lot of that stuff does not exist. We need to be able to support multiple hypervisors. The decision about whether does a product support my hypervisor or not should be academic. All the hypervisors you need to support should be there. And they should be supported simultaneously. Again, in the public cloud model, it's typically only one, the application will support multiple hypervisors, but only one at a time. That's no good. You've got to be able to have multiple hypervisors supported simultaneously. And we have to obviously deal with the security issues, both in the form of transport. This is not rocket science. We all know how to move things from one place to another down a pipe securely. But it's about setting common standards so that everybody knows, that whichever cloud it is you're going to go to, we all adopt the same one. They're all compatible, all that kind of stuff. And I would suggest that we also need the concept of a hardened hypervisor. It's a hypervisor that is secure in itself, that you can't get in from externally, and you can't open up the hood and look inside. It is physically secure. I would have thought that that is a perfectly a thing that the hypervisor manufacturers should be easily able, well, easily, it certainly should be able to do. We're not talking about technology that is again, rocket science here. We should be able to have a hardened hypervisor where it's been tested and people know that you cannot get in except through the proper door that's secured. So eliminating the issues around, can employees of the public cloud go and look under the hood, all that kind of stuff. That should be perfectly possible. So the fundamentals we've got around this thing are the management of the physical infrastructure and the virtual enterprises separated by this business policy, which is the link of the two, and the secondary items, the portability we must have, the security that must apply, and the standards that must apply really to ensure that portability and security. So how could we do this on a practical level? So take my model that we looked at earlier and start with what you might call the private cloud piece. It's one model that will apply to both public and private, but just take running it in your own data centers, running it, whether they're local or whether they're remote, just do it in your own data centers first. Be confident that the policies are working, that you can apply all of those. And at that point, using the same system, you can then introduce additional infrastructure, whether it comes from hosting providers who are able to provide you the security that you need, the confidence that you need, or whether it ultimately comes from the public cloud that, again, has grown to provide you the levels of service you need and the levels of security and compliance and visibility and control as that stuff evolves. You decide at which point you connect that in, and you still maintain, using the policies, which applications you're going to let go there. So today, for example, you may say, well, if it's a public web server, it's only got information that's available publicly on it anyway. I'm much less concerned about that. You can run that on a public cloud today. But my trading applications only stay in a data center I own. So you've got one model that does the whole thing. So in conclusion, here's a quote from Forrester. Without automation, there's no such thing as the cloud. You can't have humans doing it manually for all sorts of different reasons. Smarter automation will catapult cloud computing concepts through today's hyperbole into reality that will alter business flexibility. We think that's 100% true. So just as a finale, I'm going to show you a brief video that explains what my company does in a rather humorous way, and we'll just conclude after that.
Virtualization. Great, isn't it? We can move things around if the hardware fails or needs upgrading, or if we need more power. And we can move workloads around to more efficiently use the hardware we already have, and stop us buying more hardware we don't really need. Yep, it's pretty awesome. Yeah, except for all the ways that it isn't. See, all this moving around does make it kind of hard to track where everything is. And working out just where to put everything to get the best utilization is actually pretty difficult, especially if you have to do it over and over every day. And what about governance, security, and compliance issues? Even so-called easy deployment is still a big headache for the overstretched infrastructure team. And of course, these problems aren't getting any smaller. But hey, why worry? Cloud computing is going to fix all this, right? What if the cloud could solve the problems of virtualization? If you could fully empower your users to manage their own environments without any risk to your infrastructure, freeing your IT team to focus on delivering the most cost-effective resources at the required service levels, and have it all automatically operate according to your organization's business policies. What if you could make virtualization and the cloud work the way you need them to? Well, they can. At Abiquo, we've created a solution that fixes all the old virtualization issues and delivers the cloud just the way you need it. Abiquo provides each organizational group with total control of its own virtual enterprise, where they can configure and deploy resources any way they want to, in seconds, and without any risk to the infrastructure or anyone else's virtual enterprise. Abiquo supports all 6 major hypervisors and ends vendor lock-in by providing drag-and-drop conversion of virtual machines between any of them. It lets your IT team manage infrastructure across the globe, whether it's equipment you own or services you buy in to provide elasticity, all through a single pane of glass. Abiquo lets you control resource consumption while providing drill-down accounting for billing and chargeback. Real-time displays and statistics keep you informed and make capacity planning and efficient demand-based elasticity a reality. And Abiquo's highly sophisticated business policy ensures governance, security, and compliance requirements, as well as your business goals are consistently and automatically enforced every time. Come experience the industry's most sophisticated enterprise cloud management solution today. Abiquo.com.
So we'd love to show you that. We've got demonstrations working out on the show floor. Can't miss our booth. Come and tame your virtualization monster. We have leashes available. They work on children very well too. Just to think just one thought to finish up with. If you think about it, ultimately the only driver for enterprises to move to public cloud, given that they will need to do their own private clouds, there's no immediate stepping stone for all applications to suddenly leap to the public cloud. The only driver is going to therefore be cost saving. Because if I can do it all in my private cloud, why would I want public? Because it's cheaper. There's potentially a market in there. If that's the only driver, the only applications that are going to get moved to the public cloud are going to be where other factors like security, compliance, governance are not compromised. And that means to gain wide enterprise adoption, public cloud must start addressing enterprise needs. Thank you very much.